Hey everybody, welcome to day number 2 of unit number 3, nomenclature and bonding. We are going to move through some more electron configuration today. So today is electron configuration part 2. There's going to be 2 videos today. The first, electronic configuration, and the second will deal with some other things like Lewis dot structures and valence electrons. So this is electronic configuration part 2, which is French for 2, but we'll just put 2. Electronic configuration part 2. There's only one thing we're adding. If you're pre-AP, you may have already heard this as we were going through it yesterday, but there is one orbital that we left out that we are going to discuss. We're not going to get clear to f orbitals, but we are going to deal with d orbitals today. So if you remember back when we started yesterday, there were, bring that up a little bit, there were 3 different orbitals I told you about. I told you about s orbitals, which could hold 2 electrons, like 1s1, 1s2, because helium would be right there, 2s1, 2s2, just like that. Then there were p orbitals, which were 2p1, 2p2, 2p3, all the way through 2p6, and etc. Our p orbitals right here. There are also what are known as d orbitals. We can see down here with this shape, you can see that d orbitals look a little bit different, and that's why they have a different letter. They are called d orbitals. Our d orbitals, label these on your periodic table, are all of these here in the center, right there. These all have d orbitals. Now, this is nothing different from what we learned yesterday. We're just adding on one little step. If you go back to this sheet, you see that we get through 1s, 3s, then we get through 3p, and we get to 4s. 4s is right here. Potassium would be 4s1. Calcium would be 4s2. Then you see what comes after 4s. Whoop, right there. 3d. So this row right here is 3d. d orbitals. This is important. d orbitals. I'm going to delete our headline here. d orbitals. These will hold 10 electrons. 10. You can see this here. This is 3d. Again, comes right after 4s. 4s1, 4s2. This right here is 3d1. 3d2, 3d3, 3d4, 3d5, 3d6, 3d7, 3d8, 3d9, 3d10. So that's where we get that 10 from, right there. Now, it's odd that it's 3, right? Because we're in row 4, but this is 3d. The reason for that, if we took these down here and we place them back into our periodic table, then boom, suddenly this all gets bumped up one row and these become part of row 3. These have more in common with row 3 than they do row 4, which is why we call them 3D. To prevent any confusion, if you just follow along the process here, then you will be 111% fine. You will see clearly that after 4s, we move to 3d, and after 3d, we move to 4p. Because see, we get to 3d10, and then 4p1, 4p2, and the p and the s are the exact same as they were yesterday, so don't let that confuse you. I'll do an example, and then I'll have you do a couple examples. I'm just going to do one, and the example I'll do will be one you actually were supposed to do yesterday, selenium here, which you probably didn't do correctly if you didn't know 3d10 existed. So all that would happen is we would work our way back, so we know that selenium here is 4p1, 2, 3, 4. So that's 4p4, 4p4 right there. And then we can just work our way backwards. So if you know we end up at 4p4, we know that everything that came before 4p has to be filled in. So we have 3d10 right here, 3d10, so that would go right before it. 3d10, then 4s2, 3p6, 3s2, 2p6, 2s2, and 1s2. All you're doing is the exact same thing you did yesterday, just adding in, if you get down to this 4th row, just know you go 4s1, 4s2, then 3d1, 3d2, all the way through 3d10, and then you go back to your 4p, just like that. We're just adding in an extra little thing here. So what I want you to do, pause this, and I want you to practice on 2 of them. I want you to practice on do selenium again, do selenium, and do bromine. Just do the one right next to it. Do selenium Now we'll skip. We do selenium, and then we'll do iodine. Don't do bromine. Cross that out. Okay, selenium and iodine. Do those two. After you've done those two, so you pause the video right now, do those two. After you've done those two, show me. I'll make sure you did it correctly, and then you can move on. So pause the video, do those two. Okay, hopefully I checked off your selenium and your iodine, and you can do those correctly by using 3D right here. And then, of course, this would be, we have 5s1, 5s2, and then we go on to 4D. If you follow this, you should really have no issues at all. Okay, our next thing is noble gas notation. This makes everything that you do shorter. So let's erase this. Erased. Boom. It's amazing. Okay. This will make everything you do shorter if you use noble gas notation. What noble gas means, this column right here. Wow, that was terrible. This column. These are our noble gases. So label that column as your noble gases. Noble gases are important because they have full electron energy levels. So they all have 8 electrons. Full energy levels, 8 electrons. What that allows us to do, because before you've had to, like if you did Ca, you had to go all the way back to 1s2, right? Like Ca, this is all the way down here, this is 4s2. So you had to do 4s2, and if you followed your sheet, you would do 4s2, and then all the way back with 3p6. You go 4s2 to 3p6 to 3s2 to 2p6, and you have to write a whole bunch of stuff, and that's just so long, and I hate it. Because you have to write so much, and no one wants to write that much. So instead of doing that, something you can do if you're doing calcium, instead of going all the way back to 1s2, you can just go back to the noble gas that came right before calcium. So for calcium, you would do, if you had to do calcium, you know calcium ends up as 4s2, right? I'm going to write it with my pen so you can see that a little bit better. You know calcium ends with 4s2. You know that's how it ends. Instead of working your way all the way back and doing all the way back to 1s2 and having it really super long, you can abbreviate it. You see calcium here, you work back, you go to the row right above it, you go to the row right above calcium and find the noble gas that came right before calcium, and that's going to be argon. And what you'll do is you'll go parentheses, write AR for argon, argon, 4s2, and that will work for calcium. Because what this argon is saying is that everything up until argon, all those energy levels are 100% full. And then 4s2 represents calcium because 4s1, 4s2. So how you would find that, if I showed you argon, you would go, if I showed you argon 4s2, how would you know that's calcium? You would go, okay, I have argon. Boom. That means everything that came before argon is full, so it's got to be after argon. And then I would go, oh, 4s2, 4s1, 4s2, boom, calcium. See that? That's going to save you a lot of time. I'll do one more example, and then I want you to try a few. Another example. I love erasing. It's my favorite thing, favorite part of my day. Another example. If you did aluminum, aluminum would be 3p1 typically. 3p1. That's Spanish for one. For those of you that don't know Spanish, basically fluent. That would be 3p1. Typically, you'd have to work your way all the way back to 1s2, but instead of doing that, you just get to go to the recent noble gas, which is neon. Work your way back. You see, go to neon. So you would go neon, and the interesting thing about this is because you have to pass through here. You do, in fact, I'm sorry. So you have 3p1, and then you have to have to represent this. So you'd have to write 3s2, 3s, 3s2, and then parentheses neon, right? Just like that. So you do still have to like account for, if you, like this was an S, so you didn't have much room to go back, but if you start with a P, you have to go back and you do have to write the S, and then you have to write the noble gas. So if it was like chlorine, you'd write 3p5, right? 3p5, and then 3s2 to account for these two, and then you would have your way back to neon. So it's still a lot shorter than writing all the way back to 1s2. So that's what's called noble gas notation, because we're using the noble gas to abbreviate our notation. Noble gas notation. Okay. If you're good, go on. If not, I'm going to do one more example. Noble gas notation, we'll do it for fluorine. So you'd have, now we'll do it for bromine. Do it for bromine. You have Br, sorry, don't need to worry about writing Br. Bromine, you have 4p5. 4p5. You do still have to account for everything that up until you get to the noble gas. So you do have to do 3d10 because all of these come before you get back to argon and the noble gas. So you have to do 3d10, 3d10, and after 3d10, you're still working backwards. Use this. Where do you go after 3d10? You go to 4s2, 4s2, 4s2. I hate this thing, how I have to always refresh it. My life is so hard. Okay, 4s2, and then boom, you're back at a noble gas. So then you would just go parentheses, argon. And the noble gas just gives you a starting point, so you don't have to work all the way back to 1s2. Okay, with this video, you're done with this video. This is the paper you picked up on your way in. Keep cutting my head off a little bit like that. So what you're going to do, you can do column 1, the atomic number. You can do column 3, the electron configuration. And that is it for the front. You'll do column 1 and column 3 with this video, okay? Then you can flip over to the back, and on the back in section 1, you'll do all of section 1, all 5 of these. Then here, you're going to do all 5 of those, so 1 through 10. Actually, you can do the entire back with what we just did in that video. So you're only going to do up here, you're going to do atomic number, electron configuration. That's it for up here. On the back, you're going to answer all 20 questions. Work with the person you're sitting by. That's why you're sitting by them. They are a resource. You can be successful. Same thing as yesterday. As you have questions arise, let me know. And then if you finish early, we had a lot of people go around and help people out yesterday, and that was awesome. But there is a second video today. So good luck, and until next time, enjoy life. Enjoy electron configuration. It's the 8th most fun thing you'll do today. Farewell.